Hi everyone, I'm Julia Hyder, Senior Editor with Modern Machine Shop, and I'm your moderator for today's webinar, which is sponsored by KUKA Robotics Corporation. Adding robotic automation to machine tool processes can bring a level of apprehension and confusion on how, when, and where to begin. KUKA offers a wide range of automation technology and industrial partnerships to efficiently and effectively bring a project from conception to completion. Considering automation early on in your machine tool buying process can not only save you money and time, but it can also ensure that your machine will be efficient when it arrives at your shop. Today's webinar will cover how to save time and money by automating before you get your machine tool, finding the right automation integration partner, what to expect out of your automation supplier, and the questions to ask, and example applications and use cases. Our presenters are Ron Bergman, Key Technology Manager for Machine Tool Automation, and Philip Peloso, Business Development Manager for Machine Tool Automation at KUKA. With 30 years of experience in robotic and CNC controls, Ron brings a unique perspective to help customers automate their machine tool processes. Ron also has extensive experience with various robotic applications that require a high degree of path and/or position performance, ranging from ultra-safe entertainment to tight tolerance aerospace processes. Having worked in the field of industrial robotics and automation for over 30 years, Philip brings a mix of knowledge, experience, and passion to his role. He enjoys working collaboratively with all parties to drive solutions forward and ensure the goals of the customer are met. You can submit questions at any time for our presenters using the Q&A tab on the right, and we'll answer as many as we can at the end. There's also a handout you can check out on the right side of your screen under handouts, and there are some polls throughout the presentation, so keep an eye out for those. And finally, I wanted to let everybody know that this webinar is being recorded, and attendees will receive a link to that recording via email. So with all of that out of the way, let's get the presentation started.
Fantastic. Thank you very much for that introduction. And on behalf of my counterpart, Ron, and myself, and the entire KUKA Robotics organization, thank you very much for attending today's webinar. Our goal today is to provide you with ideas, inspiration, and things to think about before you add robotic automation to your machine tool, whether it's your first time automating or your 21st time. Before we dive into today's topic, though, a brief history on KUKA Robotics. Last year marked 125 years since KUKA was founded. The name KUKA comes from the last names of the two founders, Johann Joseph Keller and Jakob Napich, who were based out of Augsburg, Germany. So the name KUKA stands for Keller und Napich Augsburg. KUKA began as a supplier of acetylene gas, which is used in welding and cutting, went on to manufacture industrial containers and welding technologies, and then eventually robots and equipment for industrial automation. Some interesting firsts for KUKA as it pertains to robotics. KUKA developed the world's first electromechanical robot in 1973, just over 50 years ago. And 20 years ago, in 2004, it released the world's first collaborative robot. Needless to say, robotics technology runs deep in KUKA's history. So when developing robotic solutions for machine tending, several factors need to be considered when selecting the proper robot arm. One of these factors is the robot reach. Robot reach is a measurement of distance given in the metric system and can be shown in millimeters, like 600 or 760 millimeters, or in fractions of a meter, like 1.6 or 2.1 meters, and so forth. Another consideration for selecting the robot arm is the rated payload of the robot, which is a measurement of the maximum weight a robot can support. This also uses the metric system and is provided in kilograms. Robot payloads range from just a few kilograms to up to 1,000 kilograms and beyond. The payload rating for the robot must take into account not only the weight of the parts that are being handled, but also the tooling used to handle those parts, and the mass moment or the inertia of the combined load when it's in motion. Robot accuracy and repeatability come into play as well. A simplified way to think of the two topics, they're kind of interrelated. Accuracy is a measurement of how close the robot moves to the desired position in three-dimensional space, whereas repeatability is the ability of the robot to consistently reach the same position time after time. Most industrial and collaborative robots have accuracy and repeatability ratings measured in fractions of a millimeter. Lastly, another factor to consider when selecting a robot is the need to work fenceless. This brings up the topic of collaborative robots or collaborative applications, or industrial robot systems that are equipped with safety equipment, proper tooling, and control systems that allows them to work side by side with their human counterparts. We're going to see a few examples of collaborative robots, collaborative applications later in this webinar. In addition to robot arms, auxiliary equipment can be used to help give robots additional reach and flexibility to reorient the parts that are being worked on. This equipment comes in the form of linear units and rotational positioners. Examples of this equipment will be seen throughout today's webinar, and it will give you a sense of how this equipment helps expand the functionality of the robot when working with machine tools. Another technology that has really been coming into its own over the past several years is mobility. When it comes to mobility, there are many configurations available in the market today. Mobile solutions from KUKA offer various size and payloads to choose from, as well as drive and navigation systems. Moreover, the addition of industrial and collaborative robots on top of these mobile platforms opens up additional use cases to expand the reach and flexibility of automation in the machine shop. Again, you'll see examples of these systems later on. So this brings us to the first of 3 poll questions for today's webinar. I'll give this some time for everyone to answer the question. And what we're asking here is, are you intending to add robotic automation to your machining operations in the next 6 to 12 months? All right, so moving along here, let's start the discussion around steps to consider before you even get your machine tool, with the question of readiness. Is your facility ready for automation as it applies to your employees? A good place to start is through assessing the current skills of your labor, your trades, your engineering teams. Do they have experience working with advanced machinery like robots? This includes jogging and programming the robot, troubleshooting and repairing electrical control equipment, and repairing or replacing mechanical tooling. This may uncover a skills gap that can be solved with training your existing employees or hiring new employees with the skills needed. When it comes to training, there seems to be no shortage of funds and programs available at the local, state, and federal levels. If you do a quick Google search, you'll see a lot of these wins that are happening for training programs that are funded by different levels of government. And training programs are offered by both local community colleges as well as through robot OEMs. KUKA offers such training through its KUKA college facilities in Michigan and South Carolina. As you look at opportunities for automating your new machine tool, it's important to understand not only the total cost of the equipment, but the impact that automation has on your operations and whether it's even appropriate to look at automation. If your parts are large and complex with very long machining times, or the parts have the low volumes, or you don't have families of parts that can share the use of the automation equipment, automation probably won't be a wise business decision. If, however, you have parts that have high volumes or have families of parts that are generally similar in shape and configuration, and your machine cycle time aligns well with having a robot, automation might be right for you. So if it's your first time automating, my recommendation is to start off simple. Look for an easy first win. Automating parts that are relatively simple to machine, feed, handle by the robot, overall easy to process. If you take this approach, you may find there's a standard solution in the market that can be readily tailored to your needs. Standard solutions tend to be quicker in terms of delivery, are cost competitive, and have value-added software and hardware features that have been developed and honed over several iterations. A major part of being successful with your automation is to involve your team, the team that will support and maintain the equipment once it's on your floor. And once you have success in automating some of the easier applications, you might want to venture into more complex applications like 3D bin picking if the justification warrants it. All right, so you're moving along in your journey into automating your machine tool and generally understand the financial commitment it will entail. Have you considered other ways to maximize the profitability from your automation? Can you put the robot to use on tasks other than loading and unloading the machine tool? Can the robot perform a deburring operation, drill out a simple hole or face mill a non-critical feature, perform some type of inspection, or package the parts? So this video shows a fairly complex system overall, but you're seeing how the larger robot is putting to use deburring tools to help do some post-processing after the operations. You're actually getting a sneak peek into the manufacturing and machining of castings that go into our very own robots. All right, so here we are, poll question number 2. And that question is, do you currently have robotic automation in your facility? It could be 10 days or 10 years old. We're looking to see how many people on today's call currently use robots at their facility. All right, so let's go over a few ideas to help reduce the risk of your automation project as it applies to selecting the right automation partner. As with many things, it's good with taking a team approach. Use an internal team to research companies that can deliver a project based around your needs. Consider their technical bench strength, their experience in working on similar projects, their geographic location, their ability to support your project remotely if they're located a few hours away or so. Another approach is to work with your robot OEM to help recommend an automation supplier. Companies like KUKA have partner programs that can help you narrow down the field and ensure you're aligned with the correct automation partner. You want to make sure you bring the right project to the right partner. If the project's $200,000, give or take, a large integrator that typically works on projects at the $3 million level might not be a good match. And if you're looking on say automating a multi-robot project with several machining operations, part transfers, inspection stations, it can easily overwhelm a smaller company. So it's really important to engage with the right partner for your specific project. And another approach is to look for advice from your network in the industry. Find out who's had success with the companies you're researching and learn from their story. All right, so now you have the specifications for your project. You have a list of potential automation partners. Here are some next steps to take. My first recommendation is to visit the facility of the automation partner that you're considering. This will give you a chance to tour their facilities, meet with their teams, and get a chance to see how they operate, starting from reception, extending out to the plant floor, and everything in between. Are they well organized? Do they have a good process flow? Do they have a shop full of equipment, or is it waiting for the next project to show up? You'll gain a lot of insight with a visit. Another visit that will benefit you is to tour a facility that's running a system from your potential automation partner. This will allow you to see firsthand how their equipment operates, how the people at that facility interface with it, and what their feedback is on the equipment that they were sold and integrated by that partner. This might not be the easiest to get set up. You know, it's hard to maybe get into the competition, but if you can make it happen, highly recommend that you do it. All right, so now that you've identified 2 or 3 companies that check all the boxes on your requirements, you've assessed their facilities, you've seen their equipment in action, and provided them with the same specifications and expectations for your automation project, you want to request a few quotes, approach 2 to 3 companies, and ensure you're comparing apples to apples. Make sure all the features in one quotation match pretty much verbatim with the other quotation. That way you can assess based on deliverables, based on pricing, and make an informed decision. So that concludes my portion of the webinar. I hope it was insightful and informative. If you'd like to meet with me in person and talk through your automation project and learn more about KUKA, we'll be at IMTS in KUKA's booth, 236807. With that, I'm going to pass off the mic to my counterpart, Ron Bergman.
Thanks, Phil. Good afternoon, everybody. And thank you for giving us some of your valuable time today. I'll be presenting 2 topics. The first one is what to expect out of your automation supplier and the questions to ask. And the second topic will be simplify the process. Communication issues, the root of all evil and the cause of a lot of issues. Whether it's people or machines, the issues are the same. If you can't exchange information, whether it's bits, bytes, or words, you won't be making any parts. Field bus networks can definitely reduce your wiring costs for both safety and data networks. The wiring can be as simple as plugging in an Ethernet cable, for example. You really want to evaluate the cost lead time of options versus your needs. And sometimes discrete I/O, hardwired connections, and hardwired connections for your safety could be the most cost effective. For some large projects where you have a lot of wiring, a lot of data exchange, they may be better suited for safety and field bus networks. I know future production needs aren't always known, but it's always worth having a discussion early on. Adapting tooling, grippers for future parts can definitely save some money, and spending a little money up front can save you a lot of money in the long run. Sometimes small gripper changes can cost very little, but may allow you to pick up many different types of parts or family of parts, as an example. A complete new gripper design can be pretty costly after the startup. Another option to give you some flexibility is to add tool changers, so you can quickly change grippers for new parts. Here's an application video. The first one is showing a dual gripper design. And this design will handle both the raw material and the finished parts coming out of your machine tool. So it's a very efficient tool and it saves cycle time. And the second video is going to show a single gripper that can handle different size parts, but they are of similar type or similar part family. This could be a very cost-effective solution if you don't have tight cycle time requirements. Custom automation, it typically costs 50% more versus standard automation. But of course, every project can be a little different and the cost can vary a lot too. A standard system, it's really a pre-engineered solution that requires very little changes to meet your requirements for the project. One of the biggest advantages, it's a proven, tested solution, typically has lower costs since there's no major engineering required. And these systems can be turnkey as cheap as $75,000. The biggest disadvantage, they're really not very flexible and they might not fit your layout. A custom solution typically handles multiple processes. It can be integrated into your machine tool directly, or it might be part of a large production line. The main advantage, it's a very flexible solution and you get exactly what you need. So you really want to spend your budget when needed, but don't spend your money on the cool stuff that won't help your production. You know, both of these trucks, they can really do the same job, but one would obviously cost a lot more than the other. Although I do like the custom truck a lot more. Here's an example of a standard system. This again is a pre-engineered solution. It's a very simple approach for both the part handling and the gripper design. The system can be easily retrofitted to an existing machine tool. Again, very simple design and typically a very quick return on investment. The only custom parts of this system would be the tray handling for your incoming parts, and then the custom gripper or fingers to handle the parts. Here's an example of a custom solution. So this is in our robot production line. As we say, robots making robots. So this system was custom built to integrate seamlessly with the machine tool and to handle multiple secondary processes. Robots will never replace a machine tool, but they can certainly complement them and save you money. Drilling, tapping, milling are all possible for features that don't have tight tolerances. For example, if you're in the range of 10 thou to 20 thou for your part tolerance, that's in the range for robotic processing. There are many different solutions available for handling parts, and the cost can vary a lot. Conveyors, tray systems, vibratory bowl feeders, 2D, 3D vision guided robotics are some examples. Complex parts typically require complex solutions and higher cost feeding systems. Simple mechanical solutions can have a big advantage versus high tech. Keep it simple if possible. Now, 2D or 3D vision, it's definitely a great option if you really need it. My advice would be to take advantage of the experience of your automation supplier and evaluate all options available. Here's an application video. This is showing 3D vision to pick complex parts directly from an unorganized parts bin. This particular application uses a collaborative robot with a dual gripper design. These systems are pretty sophisticated. The software can automatically figure out the pick strategy and select a collision-free path to and from the parts bin. I mean, you really get a lot more for your money today, and tech suppliers continue to lower the cost and add more features to this technology. As with a lot of industries, AI is quickly becoming a game changer. Sometimes there's no need to train a part. The system can automatically identify a new part and come up with a pick strategy. You want to make sure your automation supplier explains in detail what is needed before making chips and what they expect out of your team. Identifying critical path, or high-risk task is always important, and it's always good to have a plan B. FAT, or factory acceptance test, this should really be part of your proposal and agree on it before issuing a PO. It could definitely save you a lot of headaches. If it's a turnkey system, it may include a complete design, install, training, programming your first parts, for example. And most suppliers are pretty flexible on what they can offer. And the deliverables from your automation suppliers can vary depending on their capabilities and your needs. The best way to learn a system is actually to help install, start up, and debug the automation. Including your people early on in the process can be critical. I've seen many projects fail when it really isn't possible to automate 100% of the process. A successful project is really a project that has a good return on investment and you achieve your production needs. The best automation solution is really useless if it doesn't fit your budget. Sometimes you want to take advantage of your skilled labor if possible. It's still pretty difficult to duplicate what the human hand and eye can do. The 80-20 rule, it definitely applies to automation. I've seen many applications where 80% of the tasks are completed with 20% of the budget, and the last 20%, the very difficult task, might consume 80% of your budget. So you really want to prioritize your costs versus needs. And there are definitely a lot of variables to consider, and every automation project can be a little different. Here's an application showing loading and unloading of cutter inserts into a grinding machine. In this case, the robot handles all of the simple tasks that are easy to automate. And I understand there are some really good automation inspection systems out there, but this particular customer determined that a human was needed to inspect the cutters. The reality is, the machine tool and the automation are still making the customer money, so everybody's happy. We all have struggled with home projects when we don't have the right tools for the job. I mean, typically that's half the battle. And automation is no different. You can save a lot of time and money by matching your needs with the proper technology. And sometimes it's okay for a supplier to say no. Sorry, we really don't have a solution that fits your needs. Of course, the automation supplier may lose that project, but they might gain a future customer for being upfront and honest. Again, no can be the right answer. Here's an application. This is a mobile robotic solution, loading and unloading cutters into a machine tool. This particular customer wanted no fixed automation in their plant, and they needed the automation to service multiple machines. So a mobile robot system fit the application perfectly. The system can definitely be costly, but it's a very useful tool when trying to achieve 100% automation for your facility or if you have some difficult requirements. Using a collaborative robot doesn't always mean the application is collaborative. The old saying goes, the robot can be completely safe until it picks up a knife. The entire system design should be evaluated and then determine what safety is required to protect your people. Automation suppliers are typically responsible to ensure the safety of the designs. So I would definitely ask for risk assessment up front to prove the safety of the system. Simple fencing can definitely be a cheap and safe option for protecting your people, as an example. Add-in sensors for safety can be a good option. Examples are area scanners, light curtains. The cost for this technology has been trending down over the years, and the function and features you're getting are increasing. Unfortunately, the debate between the use of industrial robots versus collaborative won't be ending anytime soon. Here's a nice example of a standard solution using a collaborative robot to load and unload. This one happens to integrate an AMR, an automated mobile robot. This is a very good example of a true collaborative application. As you can see, there are no heavy, sharp parts that are dangerous. The AMR itself has some built-in safety scanners to protect the people when they get too close. It's very typical to have two ranges for the sensors. If someone gets close, it will slow down, not stop your production. But if somebody gets too close, where there's some danger involved, the system would stop. So our third poll question of the day is, if you were involved in an automation project at your facility, did your automation supplier provide you with a simulation? Automation suppliers should really be working with 3D CAD for designing and use simulation tools to validate their designs. It's really important for a custom solution because the simulation will help you select the correct robot for reach and to make sure you have complete access to your machine tool. You can also add your facility constraints to the simulation to optimize your space, to design around physical barriers, for example. It's very typical to have low ceilings. The reality is it's very easy to move parts around inside your 3D CAD system or simulation. It really only costs you time. Definitely a lot more difficult to do it in the real world. Here's a simulation. It shows the load unload of a milling machine. You'll note that the raw material is actually placed in a regrip station. This is a very simple mechanical solution. It allows the robot to very accurately locate the part before it places it in the machine tool. And the first part of the simulation shows a relatively inefficient process where a single gripper handles both the finished part and the raw materials. This works fine if you don't have any issues with cycle time. The second part of the video that's playing shows a dual gripper design, which is definitely a lot more efficient, and you can see the reduction in cycle time. One of the big advantages of the simulation, it allows you to try different designs, quickly make changes as needed. And the final part of the simulation shows a rendering that shows the exact setup of what the real machine would look like. You can set up the camera views to show you exactly how the machine will operate in your real production environment. Sometimes it's hard to tell the difference between a simulation and a real video. You can also use your simulation to look at the workflow of your material, controlling the inflow of raw material and the outflow of finished parts. In this case, we move the finished goods or the raw materials around your machine shop. So it can show the complete process. Again, I thank you for your valuable time today, and I think we're going to open up the floor for questions and answers.
All right, thank you, Ron and Phil. Looks like we have a few questions to start off with, but there's still time to submit one. You can do that using the Q&A tab at the right of your screen. We'll do our best to get to it today, but if we're not able to get to it, someone can follow up with you via email. Okay, first question. How many quotes do you recommend for a new project?
Yeah, great question. I'll field that. Maybe Ron, you can add your content or your ideas as well. But at the very least, two, and maybe I should qualify that with the type of project. Again, if it's a smaller project where a standard solution will suffice or foot the bill, you could probably adequately get a good sense of pricing, features, availability with a couple of quotes. The more customized, the larger the project, the more involved, especially tertiary processes where you have multiple robots, multiple auxiliary pieces of automation, you will probably want to look to 3 or 4 quotes. It starts getting a little bit out of control when you look to more than maybe 4 quotes on the larger projects. But that would be my insight. Ron, what's your thoughts?
Yeah, I definitely agree. On a simple, low-cost system, 1 or 2 would be fine. But if you get into a complex system, you want to be 2 or 3, 4 quotes. And keep in mind, you want to evaluate the technology and the supplier, and not just evaluate the price. You have to take all options into consideration. Definitely do not shop based on price only.
And to further qualify that with really the last portion, the last segment Ron spoke to, finding the right automation partner with the right quote, but even the deliverables, the simulation, the 3D design, reach studies, make sure you're getting a full, it's 2024, any automation company that's worth their weight in salt should be able to provide very thorough solutions. If it's a 1-page quote, 2-page quote, might not be what's best for your needs.
Yeah, looking at the results of the poll regarding simulation, majority of the people attended had simulations included in the proposal, and that's great to hear.
Yeah, very good.
All right. Next question. Are there any example project tasks that you recommend not taking on as an end user or customer?
I could jump on that, Phil, if you want.
Yeah.
The biggest one that pops into my mind is safety. Most of the automation suppliers, they know how to make a system safe. They've learned from good, bad experiences. You want to take advantage of their experience and their know-how and leave the safety part of it up to them.
Yeah, and further to that, a lot of times an end customer might want to look to save a few dollars, and that's completely justified. You certainly want to make sure your automation supplier is open to that idea. Some of the more basic, we'll call it, some of the more simple labor components, having your in-house skilled trades, do the physical layout, physical movement, physical interconnection of the equipment is definitely something that you can easily handle in-house, or you might be able to easily handle in-house. And it's a great cost saver, and it just adds to the collective buy-in and ownership of the machine. You get a sense of ownership when you wrench on some floor legs, or you connect some sensors once a machine is delivered.
Yeah, like I mentioned in one of the slides, there's really no better way to learn a system than by helping install it, help debug it.
All right, I have one more question here. So if anybody has anything else they would like to ask, make sure to get it in as soon as possible. But for now, the next question is, what are some reasons automation projects fail or fall short of expectations?
I could jump in there, Phil, if you want.
Yeah, why don't you start, and I'll
I touched on in one of the slides. I think what I've seen over the years is people assume you have to 100% automate a process. And sometimes it's just easier to leave somebody as part of that process, or manual labor as part of the process. It can still be a big win, and it can be cost effective and good return on investment. So don't be afraid to be at 80% or 70% automation. If you still have a good return on your investment, it's still a successful project. Yeah,
and maybe springboarding off that, if there's a mismatch between expectations and deliverables, specifically if you've never done if you don't have automation in your facility, you might be expecting what you've seen on YouTube videos, or what you heard from Ron and I today, and you might have this expectation, and your automation partner, the company that you're engaging with, might not be able to deliver specifically what you're thinking you're expecting to receive. So around all aspects, around usability, interface, ease of use, fault recovery, the ability to safely return a robot to a home or safe position sometimes is easy, sometimes is difficult. Sometimes it requires a phone call. Sometimes it can be handled with a push of a single button. So that sort of thing is just understanding expectations holistically around the entire process from start to finish. Educate. I mentioned getting a team involved. It's incumbent on new users of automation to really do their diligence on understanding what's feasible, what's not feasible, what's practical, what's not practical.
All right, we have gotten another question in here. This is sort of a multi-part question. Do you offer training courses for programming using the SmartPad? And how does the programming compare to your competitors?
You want to start, Ron?
Sure. Yeah, I was reading the question too, and I saw some yellow in there. That's okay. We're all friendlies out here.
Yeah.
We definitely offer training to program from the SmartPad. The reality is all different robotic OEMs have a little different approach to programming. And it's like a lot of things. Once you know it, it's easy, but the first time might have a bit of a learning curve. And I've trained our sales guys to be able to create a program in 10 minutes. So I always joke that if a sales guy can do it, anybody can do it.
Yeah, and I guess further to the SmartPad interface, I come to this from experience in working with 11 or 12 different robot manufacturers over my 30 some odd years. And what I love about KUKA SmartPad is it gives you the best of all worlds. It gives you a 6D mouse that allows you to, from just a pure jogging standpoint, allows you to jog the robot either in tool, base, or world coordinates from the 6-degree mouse, but you also have hard keys. So if you're used to working with hard keys, you've got a hard key alternative. If you like the joystick that a couple other robot manufacturers have, you've got that. You've got a large teach pendant screen that allows you to customize, add operator interface, allows you to program right from the screen. KUKA, like several other large robotic OEMs, have a very high level language, but we also have an application layer that helps you really simplify and do quickly develop applications without having to be a coder per se. So it really touches both sides of the spectrum, from high level programming to basic programming, ease of use around the teach pendant navigation, etc.
All right, we have one more question here. Just more generally, what makes KUKA stand out compared to its competitors?
I can start with that, Phil, if you want.
Yeah. Yep.
I think, there's a lot of good robots out there. Obviously, the market is growing. There's no shortage of good products out there. One of our big advantages is our portfolio. You look at the reach and the payload of our robot line, it's second to none. The addition of different positioners to move the part around or move the robot around. We have quite a few options there. We have mobility options. What I've noticed over the years, customers want basically one-stop shopping. So they want to get as much as possible from their suppliers. And the more you can get, the lower the risk and potentially lower your costs. I guess I'll leave it at that.
Yeah, and I'll kind of springboard off that as well. I mentioned at the start, KUKA's been around for 126 years. We've been in the field of industrial robotics for over 50 years, and there are other players out there, large players in the industry who have been around as long, at least in the industrial robot space. And then there's a bunch of newcomers, and they've got a lot of great ideas and great products. Be wary of the product that you buy, and do your diligence on the total package that the different robot suppliers have. And Yeah, I mean, KUKA is very well known for its rigid robots, accurate, repeatable robots. There's a reason why many of these manufacturers, both automotive, aerospace, and many others, are utilizing our products for superior motion, superior rigidity, and longevity in the field.
Yeah, just to expand on that a little bit, maybe the folks online are probably familiar with the difference in machine tools. You look at a cheap low-end machine tool to a high-end machine tool. I think robotics is very similar. You pretty much get what you pay for. If you buy a cheap product, you're going to get a cheap product, and maybe it satisfies your needs. Maybe you want something that's disposable. You're not worried about support in 5 years. Or you want something that's going to run in your factory for the next 20 years. You know, you can call up, get spare parts, get support. Again, it's like everything in life, you kind of get what you pay for.
All right. I think that's all we have for today. I want to thank Ron, Phil, and KUKA for making this webinar possible. And thank you to everybody for listening in. You should receive an email with the link to the recording soon. Thank you for your time and enjoy the rest of your day.
Thank you, everybody.
Very good. Thank you.
Industrial intelligence.